Hello, this is going to be the third video on this series about algebraic expressions, which will hopefully make up, a much larger series on pure mathematics. My name is Ali-Ayman, and I'm an electrical and electronics engineering student at the University of Edinburgh. And today we'll be looking at factorizing expressions. So how we go about factorizing, the details of going about factorizing really depends on the expression we have at hand. But generally speaking, the rule of thumb you can always keep in mind, no matter what expression you have, is that you can write expressions as a product of their factors. Factorizing is the opposite. So factorizing an expression is the opposite of expanding the brackets of an expression. So let's look at a relatively basic expression to begin with, just so that I can illustrate this rule of thumb more clearly. So let's start off with ax plus bx. So how would we go about factorizing this? Well, we'll try to figure out the common factors in both ax and in bx. So ax is the same as a times x, and bx is the same as b times x. We can clearly see here that the common factors in both ax and bx is x. So we can rewrite ax plus bx, we can rewrite it as x times a plus b. And also, if we were to expand the brackets, x times a and x times b, we would again end up with ax plus bx. Okay, and then another few things to keep in mind are obviously that in this case, a and b are just arbitrary constants, which basically means you can make them any value you like. A and b can be 2 and 4, 5 and 6, square root of 4, and 8, so they're arbitrary constants. But they don't change. They don't change. That's what we mean when we say constant. They don't change. X, as in the previous video, X is a variable, meaning that its values, can change. We can make X anything, and we can change it, however many times we want. Now let's look at some examples of factorizing. Let's start off with the first one here, 3x plus 9. So 3x can also be written as 3 times x, and 9 can also be written as 3 times 3. So we can clearly see here that the common factors in both 3x and in 9 are 3. So we can rewrite 3x plus 9 as 3 times x plus 3. And by the way, the fact that when we expand this, we end up with ax plus bx also shows that factorizing is the opposite of expanding brackets, and this is always the case. This is always the case. Now for part B, we can rewrite x squared as x times x, and we can rewrite minus 5x as minus 5 times x. And what does that show? It basically shows that x is the common factor we're looking for in both x squared and minus 5x. And as a result, we can rewrite this as x times x minus 5. So this is the final answer. We have factorized x squared minus 5x by taking out, if you'd like, the x. Okay, now for the third example, we've got 8x squared plus 20x. But this time it's not only the variables that can be factored out, not just x. Even 8 and 20 now also have common factors. 8x squared, we can rewrite it as 4 times 2 times x, and we can rewrite 20x as 4 times 5 times x. So we can see here that we've got two common factors in both 8x squared and in 20x, which are 4 and x. And as a result, we can factor out both 4 and x, and the result is 4x times 2x plus 5. Okay, now for part D, we've got 9x squared y plus 15x y squared. So there are a lot more common factors now in this case. We've got common factors for two variables this time, x and y, and we've got common factors in the constant, 9 and 15. So we'll start off with 9 and 15. The common factors of 9 and 15 are 3, because 3 times 3 is 9, and 3 times 5 is 15. Now for x, we've got x in both terms. We've got two x's here, so x times x, which gives us x squared, and we've got 1x here. So it follows that we can take out 1x. And similarly for y, we've got 1y here and 2 here, because y times y is y squared, so we can take out 1y. Then we open a bracket. 3 times 3 is 9, so we have to write a 3 there. And then x times x gives us the x squared we've got here, so we write x there. And then we add 5, because 5 times 3 is 15. But we also add another y, because y times y is y squared, and we put no x because this second term only has 1x. And when we expand this, we will get 9x squared y plus 15x y squared. Part E, we've got 3x squared minus 9xy. In both terms, 3x squared and minus 9xy, we've got two common factors. We've got two common factors, one for 3 and 9, and one for x squared and x. So we can take out 3, and we can also take out the x, because we've got two x's here and one there. So this becomes 3x times x minus 3y. And notice we don't take out the y as we did here, because y is only present in one of the terms. Y is only present in the second term in this case. Y is not present in the first term, so we cannot take it out. We cannot factorize y out of the expression. This is called a quadratic expression. And the form of a quadratic expression is as written here. We write it as ax squared plus bx plus c, where a, b, and c can be any real number, but a does not equal 0. So sorry about that. A cannot equal 0. Cannot equal 0, but can equal anything else, as can b and c. B and c can be 0. So to factorize a quadratic expression, there's a different methodology we must follow, and I've listed them here. So the first step, so we'll do the step by step. So step 1, as I've said here, is to find two factors of AC that add up to B. So what do I mean by that? I'll show you. So AC is the same as A times C. A times C is AC. So we basically need to find two factors of AC which add to give B. Okay, we need to find two factors of AC which add to give B. So two numbers which would multiply. So two numbers which would multiply to give us AC, and when we add them, we get B. That's the first step. For the sake of simplicity, I'll write down an actual quadratic expression. Okay, so here we've got x squared plus 2x plus 1. Now, we've got a 1 there. 1 times 1 is 1, and that, if you'd like, is AC. So what two numbers times to, multiply to make 1, and when you add them, give us 2? Well, two numbers which do this are, again, 1 and 1, which gives 1, and 1 plus 1, sorry, is 2, which is B. Okay. Now the second step is to rewrite the B term as the sum of the two factors. So we have to rewrite 2x as the sum of the two factors 1 and 1. So we rewrite this as x squared plus x plus x plus 1. Okay. And now we factorize each pair of terms. So we will factorize x squared and x all in one go, and we'll factorize x plus 1. So this will factorize to x times x plus 1 plus 1 times x plus 1. And we can now factor this as well. We can now factor this. So what do we call that? We call it taking out the common factor. In this case, the common factor is x plus 1. So we can take it out, and we'll end up with x plus 1, and in another brackets, x plus 1. And if you've seen my previous video, you'll know that this simplifies to x plus 1 all squared. Okay, now let's look at a second set of examples. The first one being x squared minus 5x minus 6. So again, to factorize this, we've got a 1 here. So 1 times minus 6 is minus 6. So what two numbers multiply to give us minus 6 and add to give us minus 5? So those numbers will be minus 6 and 1. Gives us minus 6, and minus 6 plus 1 gives us minus 5, as we can see there. Now we have to rewrite this entire expression. So x squared minus 5x minus 6, we rewrite it as the sum of the sum of these factors. So the sum of minus 6 and 1x. This will become minus 6x plus x minus 6. Then we factorize each pair of terms at once. So we get, for the first pair, x is the common factor in both x squared and minus 6x. So we end up with x times x minus 6. And the only common factor between x and minus 6 is just 1. So we write plus 1 times x minus 6. And now the common factors in both x times x minus 6 and 1 times x minus 6 is, as you may have guessed, x minus 6. And we can rewrite all of this as a result as x minus 6, and that is the final answer. Okay, now for the second example in this set, we've got x squared plus 6x plus 8. So as before, we'll multiply a and c. So 1 times 8, which gives us 8. And then we have to think of two numbers which will multiply to give us 8 and add to give us plus 6, which in this case will be 4 and 2. 4 times 2 is 8, and 4 plus 2 is 6. So we can rewrite x squared plus 6x plus 8 as x squared plus 2x plus 4x plus 8. And then factorizing each pair of terms, so x squared, so x squared and 2x and 4x and 8. That will give us the x squared and 2x, the only common factor we've got is x, so we'll get x times x plus 2, and then for 4x and 8, the common factors we've got are 4. So plus 4 times x plus 2, and then we simplify this whole expression, and we end up with x plus 2 times x plus 4. Because x plus 2 is a common factor in both x times x plus 2 and 4 times x plus 2. So this is the final answer. Okay, now for the third example for part C. We've got 6x squared minus 11x minus 10. Again, now this time the coefficient before x squared is not 1, it's 6. But the same rules apply. We've got 6 times negative 10, which is negative 60. Now we have to think of two numbers which times to give minus 60 and add to give us minus 11. And these two numbers will be minus 15 and 4. So multiplying minus 15 and 4 gives us minus 60, and adding minus 15 and 4 gives us minus 11. You can rewrite 6x squared plus, 6x squared minus 11x minus 10. You can rewrite it as 6x squared minus 15x plus 4x minus 10. And now we factorize this whole expression in pairs of terms, so the first two terms and the last two terms, as we did before. The common factors of 6x squared and minus 15x will be 3 and x. So we can rewrite this as 3x times 2x minus 5. And then for 4x and for minus 10, the common factors are, the only common factor is 2. So we can rewrite this as 2 times 2x minus 5. Now we've got common factors in both terms, which is 2x minus 5. And we can factorize this to give us 2x minus 5 times 3x plus 2, which is the final answer. Okay, for part D, we've got x squared minus 25. Now, there's a rule we have to use here. This is not an example we've covered before, so I'll explain this rule. So when we have two square numbers in an expression, and one is being subtracted by the other, we use a rule called the difference of two squares. Let me show you what I mean. We can rewrite x squared minus 25 as x minus 5 and x plus 5. If you look at this more closely, you'll see that the square root of x squared is x and the square root of 25 is 5. So literally this uses the exact same concepts we've covered above, But it's just worth noting that this can be done very quickly when you see a situation like this, when you see a variable raised to the power 2 and you've got a constant which is a square, which can be square rooted. You can just do this, very quickly. Because the square root of 25 is plus and minus 5. So let me show you how this would be done normally. So x squared minus 25 is the same as x squared plus 0x minus 25. And again, 1 times minus 25 is minus 25. But this time when we want to find two numbers that multiply to give us minus 25 and add to give us 0, we just get minus 5 and 5. And then minus 5 plus 5 is 0. So you will end up with the same answer. Let me just show you for this. We can rewrite the above expression as x squared minus 5x plus 5x minus 25, and then factorize each pairs of terms. We get x minus 5 plus 5 x minus 5, and then this all factors out. And we get x minus 5 and x plus 5. So basically, what I'm trying to say is that when we've got a variable raised to the power 2 and a square number, and they're both and one is being subtracted by the other, you can just go right into it. You can find the square root of x squared and the square root of 5, open two brackets, put an x in one and an x in another, and then put the product of the square root of the constant, a plus and a minus number, or both solutions, I should say, in the remaining slots of the brackets. But if that seems a bit too tedious, you can again just use the the method we've been looking at previously. That works just fine. But just to keep in mind that this is a little different, and this is a situation this is a unique situation we encounter when it comes to looking at quadratic expressions. Okay, now for the last part in this set of examples, for part E, we've got 4x squared minus 9y squared. So let's look at it here. This time using the method we looked at before isn't, I wouldn't say is the best way. But this involves what we looked at before, the difference of two squares. This time we've got two variables raised to the power 2, and both are multiplied by constants, which are powers of 2, or powers of 2 in the first case and powers of 3 in the second case. So what's the square root of 4x squared? Square root of 4x squared is simply 2x, and the square root of 9y squared is simply 3y. Like I said before, we just put in the two x's. So we open up, sorry, what I said was open up two sets of brackets, place the square root of the x squared term, and then for the 9y squared, you can just put a negative and positive sign here, and then just put in 3y and 3y. And if you notice, expanding this will again give us 4x squared minus 9y squared, because 6xy, when you expand this, you'll get, let me just expand it just for this, for showing you. So that equals 4x squared plus 6xy minus 6xy minus 9y squared. As you can see, this will simplify. the 6xy and the minus 6xy will cancel out. Because 6 minus 6 is 0, and both are multiplied by the same variable, so this will all cancel out. And the final answer, since this question wanted us to factorize, is 2x minus 3 times 2x plus 3. Okay, now for the third set of examples. This time we've got an x cubed. This is the first time we've seen this. And the same, concept applies. The common factors in both minus 2x squared and in x cubed, so in both minus 2x squared and x cubed, is x squared. How do I know this? Well, because x cubed can be rewritten as x times x, which is the same as x squared times x. And obviously minus 2x squared can also be rewritten as minus 2 times x squared. And it becomes apparent that x squared is a factor of both x cubed and minus 2x squared. So we can rewrite x cubed minus 2x squared as x squared times x minus 2. So we're taking out the x squared. Okay, now for part B, we've got x cubed minus 25x. This time, x squared isn't a factor of both x cubed and minus 25x, but what is a factor is just x. So we can take x out of x cubed and out of minus 25x, and we get x times x squared minus 25. But this isn't the end. We can simplify this further. We can factorize x squared minus 25 as we did before. X squared minus 25 is a quadratic expression. And the square root of x is x, and the square root of 25 is 5. So we can rewrite this, opening two sets of brackets, and writing x here and x there, and then positive and negative, and then just placing 5. So x cubed minus 25x is equal to x times x plus 5 times x minus 5. Why? Because x is a common factor in both x cubed minus 25x and x squared minus 25 can also be factorized using the difference of two squares. Do you understand? It's in the name. The difference of two squares. We've got one squared here and one squared number there, so two squared numbers, and we're subtracting them. In other words, the difference. Okay, for part C, we have x cubed plus 3x squared minus 10x. Again, we'll start off by finding the common factors in all the terms we have here. So in x cubed and in 3x squared and in minus 10x, which in this case is just x. So we can rewrite this expression as x times x squared plus 3x minus 10. But we can, as you can imagine, we can factorize this even further. We have a quadratic expression here. And this quadratic expression can be further factorized. So let's look at it separately. X squared plus 3x minus 10. So we have a 1 here. The coefficient of x squared is just 1. 1 times minus 10 is minus 10. And then we have to find two numbers which multiply to give us minus 10 and add to give us 3. And the answer to that is 5 and minus 2. 5 times minus 2 is minus 10. 5 plus minus 2 is simply 3. So we can rewrite x squared plus 3x minus 10 as x squared plus 5x, or just to make it simpler, x squared minus 2x plus 5x minus 10. And then simplifying the first two terms and the last two terms, we end up, sorry, not simplifying, factorizing the first two terms and the last two terms, we end up with x times x minus 2 and 5 times x minus 2, because x is a common factor in both x squared and minus 2x, and 5 is a common factor in both 5x and minus 10. So this all factorizes, because x minus 2 is now a factor in both x and 5. So we end up with x minus 2 times x plus 5. So the final answer will be x cubed, so x cubed plus 3x squared minus 10x is equal to x times x minus 2 times x plus 5. Right, okay. So I'll show you how I would tackle this question in an exam style situation as I did last time. So watch carefully, and then once I'm done, you can check your answers with what I'm about to present. So yeah, so 6x cubed plus 7x squared minus 5x is equal to x times 6x squared plus 7x minus 5, because x is is a common factor in all terms, so we can take x out of the expression. So now we have to factorize 6x squared plus 7x minus 5. 6 times minus 5 is minus 30. So two numbers that multiply to give us minus 30 and add to give us 7 are 10 and minus 3. And 10 plus minus 3 is 7. So we can rewrite 6x squared plus 7x minus 5 as 6x squared minus 3x plus 10x minus 5. And then we factorize the first two terms, the first and last two terms in this expression, and common factor of 6x squared and minus 3x is 3x. So we end up with 3x times 2x minus 1, and common factor of 10x and minus 5 is just 5. And then the common factor in both terms here is 2x minus 1, so we can factor out 2x minus 1, and this will give us 2x minus 1 times 3x plus. So the final answer is x times 2x minus 1 times 3x plus 5. And just to recap, factorizing is basically the process of writing expressions as a product of their factor, and factorizing is the opposite of expanding brackets. Depending on what kind of expression we have, the process through which we go to factorize that particular expression may differ. For example, for quadratic expressions, there's a process we would follow, and this has been illustrated here. So this is the end of the video. I hope you've enjoyed and learned, learned the concepts trying to be put forward in this video. If you haven't watched the previous videos, if you like this video, please like, share, and subscribe. And stay tuned for more videos on this series, and then hopefully after that on other subjects. Goodbye.